So everybody, good morning. So purposely, let's get started. So to begin, let's start with a quick student to help you recap what we learned in the last two classes. So just go to the website, join in my quiz.com. So turn on your laptop.
You can use your laptop, your phone, it's fine for this class anyway. All right, guys, so this is all information we've already kind of gone over. And don't stress too much. It's not going to be a formal grade here. It's just really what you remember. Joyce, can you show the code again?
7015 4493.
All good?
Yes.
Yes. You can just start.
Okay.
Oh, we can start now.
Yeah, you can start.
Okay.
So the questions.
We start.
Yeah, go ahead. Start. All right, guys, if everyone's finished, you can put down your phones. We've got a couple more left.
Okay, everyone, let's look at a question here. The first question, natural selection results in change in the population's inheritance traits over time. What is inheritance? Does anyone know what is inheritance?
Is it because they were born with the traits?
What are the traits?
Inherited, yeah, they're born with those traits. Something that they're born with genetically has.
Yes, it's about genes. So next question, we got 85% accuracy. Which of the following is not an example of natural selection? Someone choose bacteria becoming resistant to antibiotics. Why this one is not?
why would that one be bacteria becoming resistant to antibiotics?
Because we didn't do it, I didn't do it. Sorry.
Because we didn't do it, right? The question was, which of the following is not an example of natural selection? That's definitely people selectively breeding hamsters for size. We're doing that. Bacteria just had that genetically resistant gene.
Okay, the next one. What is the best definition of animal adaptation? So here is the definition: characteristics that help animals survive. And the next one, the process of choosing parent organisms for desired characteristics is called. So here, the key word is desired characteristics. So artificial selection. The next one, what is an example of artificial selection? Someone letting dogs choose their own mate. Why this is not artificial selection? Because people don't choose it. It's not depend on human desire. And someone choose letting plants pollinate on their own. Also, this does not depend on human desire. Next, the last question. Organisms from the same species can vary in one, physical appearance, to genetic makeup. So this is variation. So one, choose overproduction, selection, adaptation. So because vary, this is the keyword. So it's variation. So that's all right. This is the recap of what we learned in the last two classes. Now let's move on to the next part, and Sing will guide you through it.
All right, guys, so everyone should have your booklets on the tables there. Each one of you should have one. If you don't have one, please raise your hand. I'll give you one. There you go. There you go. All right, so up till now, we've been looking at the mechanisms, right? The things that lead to evolution, the things that cause evolution, right? Talked about selected agents, talked about natural selection, we talked about artificial selection, the things that lead to evolution. Now we're going to start talking about, well, what evidence do we have? How do we know this is actually happening? How do we know, like, all living creatures on this planet evolved from ancestors? So by the end of this lesson, we need to be able to answer these two questions. First one, what evidence do we have for evolution? All right, I'm going to try to answer that question by the end of this lesson. Second one, what are homologous and analogous structures? No, you don't have any idea what that means, but by the end of this lesson, you should be able to answer that question there and give a definition for each of those terms. All right, so the lesson is going to be about homologous structures and analogous structures first. All right, when we look at these two pictures here, we see sharks and dolphins. They're very similar, don't they? You would think, oh, okay, well, evolution is real, then definitely those two are related. I mean, it must have came from something that was very similar to them. It's actually not true, and when we look more deeply into this, we'll understand why. The success criteria for today is really just for you guys here and now. By the end of this lesson, understanding it, identification, students, you guys should be able to correctly define, identify, and justify examples of homologous structures. Analogous structures, demonstrating an understanding of the relevance to the theory of evolution. How does that actually help us confirm, yes, evolution is real? And you'll also be doing a digital presentation in the second part of the class. And this is so that you can proficiently use digital platforms. It'll be your choice of PowerPoint or Canva to use. You'll create and present a clear, organized, and informative presentation that includes definitions, examples, justifications, and the relevance to the theory of evolution. All right, so first of all, let's flip over to that first page. We're going to talk about homologous structures and what they are. All right, a homologous structure is a physical characteristic, all right, something physically that we can see an animal has in different species that has the same basic structure, it looks very similar, but evolved to serve different functions. It looks similar, but it evolved to serve different functions. So make sure you guys write down the notes as we go. This is going to be an excellent study resource for you when we get to test time. Yep. Guys, we're all going to go to SACE, right? Hopefully, you guys are going to choose science, and you're going to have to be given an exam. So you got to get ready for that. All right, let's just take a look at that picture there. Now, if we look at a human limb, I know it's already there on your pages there, but if we look at human limb, we see these bones here: the humerus, the radius, the ulna, the carpals, the metacarpals, and the phalanges. That's pretty clear how those are kind of distinct and different in that limb. If we look at the other animals that you have there on your page, look at cats, whales, and bats. They too have the same type of structure. So this is a characteristic, physical characteristic they have, which is very similar. Right? Same basic structure. They have humeruses, they have radius, they have an ulna, they have carpals. You can see the yellow, which leads into the metacarpals and the phalanges, which are pretty much the fingers, the ends. So they have those same basic structures. They may be shaped a little differently, maybe longer or shorter. Yes, definitely. But makes sense, right? We can see it right there in front of us. How those four animals, four species really, have the same structures. So these are pentadactyl limbs, and this is just an example of homologous structures. Just one example. I'm sure we can come up with many, many different types of examples as well. Now, if we go to the next page, if different species have homologous structures, they must possess similar genes that code for that structure. Now, this is definitely something you guys are going to learn next year in year 11 biology. But the genes code for these structures, meaning the genes that we have inside of our DNA, they are read, and then as we are getting into from the zygote and we're becoming fetuses, at that point our genes are being read and we're developing these structures. So if we can kind of imagine, okay, each one of these animals had that gene, which enabled it to develop that structure. If it didn't have that gene, it would not have developed that structure. So this leads us to believe, okay, they must be similar genetically. If they're developing the same structure, they must have the same type of gene in them, right? So when two species share a homologous structure, it is strong evidence that the two species evolved from a common ancestor. So if we look at humans, cats, whales, bats, because they have the same homologous structures, well, it's reasonable to say, okay, they must come from a common ancestor that have similar genes, that have the same type of genes. All right, now, has everybody filled in their blanks there on that page? All right, now there's something called analogous structures. All right, we know what homologous structures are now. Analogous structures, physical characteristics. Again, physically something in different species that have very different underlying structures but serve similar functions. All right, what does that mean? Okay, so the structure is different. I mean, it looks very different. Doesn't look the same, but it serves the same function. I'll ask you guys to guess, but that picture on your sheets there should give it away. You see there's an insect with wings, which is very different from a bird with wings, but they serve the same function. They help it to fly. Structure is very different, but it serves the same function. Now, dolphins and sharks. Now, dolphins and sharks, if we look at the ends there, tails, structure is very different, right? Sharks, the fin is vertical, and it moves side to side horizontally, helping it to swim. Whereas dolphins, spins horizontal and it moves vertically, helping it to swim. Different structure, but serving the same function, helping it to swim. Different structure, wings of an insect, wings of a bird, but serving the same function, helping it to fly. Is that clear, guys? Anybody have questions on what a homologous structure is and what an analogous structure is? All right. Let's move on then.
Question.
Yes.
So you can't always see, you can't look at two animals and just see that they have a homologous. Right? Like a bat and a hen.
That's right, yeah, we cannot
Just
look
see it.
and just see. You know, we can see, okay, similar shapes there, but they may serve different functions. Or, they look very different, but they serve the same function. Is that clear? All right. Now let's just fill out this table here, and hopefully this will help us kind of understand it a little bit better. All right? Analogous structures are significantly different. The genes, therefore, those three dots, remember guys, we talked about this before. Those three dots means therefore. In science, we like to shorten things. That means therefore. Therefore, the genes responsible for the structures are significantly different. Why would you think that is? What's the question? Again, analogous structures are significantly different. Therefore, the genes responsible for the structures are significantly different.
Because they would not be able to be inherited. So the genes therefore must be significantly different as well.
When could we say that the genes have to be similar? They must be similar. When would we say that?
When it's a direct parent-child family relationship.
Right, but looking at structures, what is this? Anybody else give me an answer here? When could we say that the genes must be similar?
When we can observe homologous
Structures, homologous structures tells us that the genes must come from the same ones because they have developed the same structures. They look very similar to each other. All right, so when two species share an analogous structure, it is strong evidence that they do not share a recent common ancestor. Now here, we'll make a table, that way we can clearly understand the difference between homologous and analogous. Homologous structures, similar fundamental structure, yeah. Analogous structures, different fundamental structure. It looks different. Fundamentally, the structure is different. Like the wings of a fly, as compared to the wings of a parrot. Structure is fundamentally very different.
Do the homologous structures have to have a different function? Or could it be like a monkey and a human, they kind of both hands that do the same thing?
That's absolutely true. They could have a very similar function. Very similar function. They have the exact same function, then it's probably the same species. There are things that monkeys can do with their hands, but or there are things that we can do with our hands, but monkeys cannot. Very similar structures, but sometimes the functions change, which is really how we have opposing phenomena, which makes us very different than monkeys. All right, guys, make sure you fill out those blanks. And the other thing that I want you guys to kind of remember is, all right, homologous structures, similar, they look very similar. They may have different functions. It leads us to believe they come from a common ancestor. This is called divergent evolution. Analogous structures, different fundamental structures, looks totally different. The structure is completely different, but they serve the same function. This tells us that it's different ancestry. This is called convergent evolution. All right, so I know it still may be a little bit confusing, which is why we're going to spend some time really looking at homologous structures and analogous structures. I gave you a few examples already. And we're going to go into this next activity, and you guys are going to be the ones coming up with the homologous and the analogous structures. And Joyce will let you know what you're doing here.
Thank you. So next activity will be a group activity. You will do a digital presentation and you will use a digital platform such as Canva or PowerPoint to create your presentation. I will choose an example. So you can work in 2 or 3 in a group. Your group presentation must include the following sections, 1 slide per section. So the first definition, you choose analog structures or homolog structures. So you put definition in the first slide. The second one is examples with pictures. We already showed you some examples, so you're gonna come up with more examples about it. And the third slide is justification of why it is homologous or analogous. So by justification, I need you to look at the comparison here. So for homologous, they have similar fundamental structure but different functions. You're gonna explain what are the similar fundamental structures, what are the different functions. If you choose analogous structures, you're gonna explain also these 2 parts, the fundamental structures and some functions.
So I need you guys to explain to us, you need in your presentation, what the structure is, how is it similar, or how is it different? And then the function, how is it similar or how is it different? Okay?
All right. So, for example, you have already saw the examples here. Homologous. So here are just 4 examples for pentadactyl limb. So pentadactyl. Penta means 5. Remember pentagon, 5. 5 sides, 5 ankles. So pentadactyl means 5 digital. So they have 5 digital. So here are just 4 examples. You can expand it, or you can choose other examples you are interested in. And for analogous, we have other examples here, or you can choose organs, parts, they have similar function, but different structure. It depends on your preference. So this is the 3rd slide. The 4th slide, how it supports the theory of evolution. So we talk about divergent evolution and convergent evolution and dig into it and make a connection of your examples. So, by the way, we have, if you spend 5 or 10 minutes, you still don't know how to choose which examples. So we have some options here as the last resort. So you can ask us to give some options. Also, it's the last resort. By the way, if you have any questions, please raise your hand and we'll come to you. Okay, let's get started.
Everything is coming fast.
Reading,
Wow. Thank you. I have to
Do you guys understand what we're looking for? All right, so just any example that you choose to research, and then give an explanation. How it's used.
I felt very fun.
All right, guys, fast forward to the end of the lesson. Here it comes, last 2 minutes. There it is. All right, guys, I came around to you guys and I saw some of you were, we were struggling to find maybe which structures to choose, so I gave you this piece of paper. This is all imagination. I gave you this piece of paper, and you were able to choose from those 3 homologous and 3 analogous, because you were having such difficulty figuring out, hey, which one should I do? So I gave you some choices there. All right. Okay, guys, as far as you can go in, that's fine. We'll definitely present these in the next lesson. You'll have 3 to 5 minutes to give your presentation, so please work on it and be ready. We'll draw straws for who goes first and who goes second, who goes third. Is that good? Yeah. All right. All right, guys, have a good day. Guys, Martha should have sent you the link already. I think she sent you the link already. Guys, no, you do not have to do the presentation.
Yes, you do.